So welcome to the next video. We are now approximating the statistical analysis part. We have the data that is almost prepared. I know there will be a small mistake that I'm going to show you later, something we forgot. But for now, we're good. What we want to know now. Usually, if you write your paper or if you write your thesis, you have to provide a description of your sample. You have to know, first of all, what is how many male, how many female participated in your study, how many people were assigned to which of the experimental groups, fear, anger, and control group, and you would like to know the average age and the standard deviation. These are the basic things that you need to make. Think about two types of variables. Actually, there are four types of variables, but we're going to work with two now. The one is scalable variable, like age. It can be any number. Actually, it cannot be lower than 0, but it can go probably up to 100, 110 years and so on. The temperature cannot be lower than 273 Celsius, but it can go to millions of Celsius degrees upfront. And there are variables that cannot be expressed in numbers, like being a male or female. So you cannot say that if male is 1 and female is 0, then male is 10 times better than female. You cannot say they are either male or female, or diverse, or whatever you want to select that. And you had anger and fear, and if we have in this event fear is 2 and anger is 1, it doesn't mean that fear is 2 times anger. In this event, we talk about nominal or categorical variables, and they're usually indicated by this sign. But SPSS will introduce some signs. It doesn't know what you want to say. That's why usually you have to say it manually. And that is why we did this operation, because all the scales, Likert scale, they are ordinal. You see, it will not be taken automatically. You just need to say these are the ordinal scales. So the ordinal scales and so on. And gender manipulation group, they are nominal or categorical. It is the synonym. Age is scale. It is a scale. A year of birth is scale, and yeah, the other variables are here ordinal. I'm just too lazy to enter them all. What kind of analysis we have to run with these variables? If the variable is scalable, age, we can run statistics on minimum, maximum, mean, median, and standard deviation, if you want standard error. And this is the statistics that you need to show how good your sample is, because if your age, let's say, is on average 35 and has very small standard deviation of 2, then you can say that more or less people are around 35. So like somebody will be 29, 31, 40, and so on, but you will have very consistent sample. If your standard deviation equals to 20, then it is very likely we have a lot of young people, a lot of old people. On average, the average age at 35, but actually can happen that you have huge groups of very young or very old people. How you do it? Go to Analyze, go to Descriptives, and go to Descriptives. And here you have to define what kind of variables you do. For descriptives, we take the scalable variable. In our event, it's only one variable, it's age. We can take year of birth, but it is the same. We just calculated age by 2025 minus year of birth. You go to options, and in options, you have data that you can let you show. First of all, mean, standard deviation, minimum, maximum. These are the good ways to show something. You can calculate the median. I don't remember how exactly, but I think, yeah, it's not here. And for the analysis, sometimes you need also to calculate kurtosis and skewness, because it will show you the data distribution. If the data too kurtoid or too skewed, then the parametric normal test will not be eligible. You will have to run additional tests. For now, we make it simple. That's why I'm not going to, although I don't remember the cutoff values. I think about up to 2, it should be good. Let's click this 2 and see what is going to happen. And what happens also in SPSS, you see the table, but actually there are 2 windows that are running. You don't see it, and it was on the second screen. It looks like this. So each time I made my coding, it was also reported me that I, as you see, manipulation control group was recorded into something. So all the things I did, they are also showed in the output. It's recommended to save the output, because then you can follow and understand what you did. But there is also a trick that you have to do. Let's see whether it will allow me to do it. Go to File, Edit, Options. In the options, if you click it, you get this window. Go to Output. No, not Output, sorry, Viewer. And put the cross here. I don't know why, but SPSS deletes this tick from this tick box every new update. That's why take care that it is shown here. If you added here, then each time you make a command, not only the result will be shown, but also the command. And then you can follow much better what you have done. Just to explain how it looked like, just let's find my second SPSS window. You see, all these things are my commands. If I hadn't checked it, then you wouldn't have seen. The variables would appear, but you wouldn't understand that I coded them. They would appear in the data set, but you will not see how they appear there. The same here. I just made a calculation with the year of birth and have seen what are the, whatever, replacing missing values. So it shows you that I tried to replace missing values by the mean of series of the year of birth. If I wouldn't have ticked it, you wouldn't just see it, you would just see the final output table and you would see the final variable, but you wouldn't know what I have done. So I recommend you, first of all, it is easier to understand, and second, imagine you get a new data set and you have to run the same statistics. You can simply copy this code and make it run using syntax. If interested, leave me a comment and I can record a video about how to do it. So don't forget to do it. Now coming back to our data, age. In options, we selected standard deviation, minimum, maximum, mean. And also click curtices and skewness just to see whether we're eligible to apply the test that I want to apply. Click on OK. And we have here this nice table. So first of all, you see what I did, descriptives. This is the command that I just made for the variable age. And in statistics, I want to see on mean, standard deviation, minimum, maximum, curtices and skewness. And we see how many people. I have 167 people participating in this study. The minimum age was 25, the maximum 42. Mean statistic, no idea what it is. Then we have the standard deviation, which is 354, which means it's very consistent sample, like more or less people around 30, 35. And skewness is far below 2, and kurtosis is also far below 2. Minus 1.7, minus 3.9. It means that data is normally distributed. If we depict the data, make a graph, it will most likely be normally distributed. We can try to do it. I don't remember exactly, but let's make it using chart builder. And in the chart builder, we'll need something like this, I assume. And we want to do it for the variable age. Let's try to see what it will work. Where am I here? No, it is definitely a bar chart. Okay, probably we have to first of all put it here. And then we add age. I don't remember, what should it be? Age like this, or should the age be here? Good question. Let's try it with the X and age. So we have different ages and we'll see how many people will be there. Click on OK. And if we're lucky, we will have something like a normal distribution graph. At least based on data, yeah, it looks like pretty like a normal, nice bell curve, as you see. Not so many people who are too old, not so many who are too young, so more or less it's like normal distribution curve, and the skewness and kurtosis, they show exactly what happens. So kurtosis would show in how much it is flat or not flat, and skewness would show whether it's too much on the right-hand side or on the left-hand side. So it can be a kind of this type of distribution or this type of distribution. So this is what you get with the statistics. Anyway, it's additional statistic. If you report it, it's nice to know, especially if you're going to run some tests with the statistics. For descriptive statistics, for the scalable variables, it's actually that was it. It can also be your experience, it can also be, I don't know, size of the firm where you're working, so all the stuff you can run here, all the scalable variables that have the precise number. Now we have to find out how many males, how many females, and we need to find out how many people in each group, control group, anger here. We go to Analyze, Descriptives, and this time we take frequencies, because we cannot calculate the mean gender. Mean gender, let's say 0.7, will not say anything. That's why it makes no sense with categorical or nominal variables. Frequencies. And for this variable, we need to take our manipulation recoded or gender recoded, both of them. Display frequency tables, nice. We go to statistics, and sometimes you can also make mean, median, mode. Here is the median. So you can run the median with this test. But in this one, mean makes no sense, median makes no sense, mode makes no sense, just because these are nominal variables. Click on continue, and OK. And now we know. So first of all, we had 84 females and 83 males, so very equal distributed groups. And we have 47 people who landed in control group, 50 in anger group, and 17 fear group. So 70 fear group is a bit over distributed, but it happened coincidentally. The data was random, but more or less it's not bad. In some cases, if the groups are small, it can be bad, but it's not the goal of today's video to talk about the correct distribution of the answers within the experimental groups. And this is what you're going to report in your sample description. You say the average age was 34.89, usually 3 numbers after 0, 898. Minimum age was 25, maximum 42. Overall, 167 people participated in the study, from whom 84 were females, 83 were males. After distribution into different groups, the control group, or to the control group, 47 people were assigned, anger group 50 people, fear group 70 people. Overall, 167, so you can always see the numbers add up. You can also see here the percentage if you need, so more or less it's good that we can describe it this way. Now I think the last thing that I want to show you with descriptive statistics is how to calculate median, because in the frequencies test, as I just discovered, we can also calculate the median. So let's take age, and in statistics we also click on median. For some reason it was not in the descriptives test, but let's click on, and we know the median is 35 years. So mean age was 34.89 and median was 35. So very congruent data set without too many old people, too many young people, so it's a kind of, we are good to go. And in this video we learned actually what you have to write into your sample statistics, into your sample description in your thesis. See you in the next video.